So hello everyone, welcome to this session. So in our last class we had stopped with the Legendre equations, right? We have dealt with the Legendre equation problems along with the concept. I have explained it and I have solved two problems, right? Okay, so in this session we are going to continue with those problems only. We have two more questions, right? We'll solve them. So this goes your first question of this session, that is 2x minus 1 the whole square d square y by dx square plus 2x minus 1 into dy by dx minus 2y is equal to 8x square minus 2x plus 3. So now the first thing you might be saying that this is of the form of the third type polynomial, right? But no, this is in these kind of problems for Cauchys and Legendres, whatever is the value of r of x, we need to keep it as it is and we need to replace it by r of z, and we need to put the value of wherever x is there, we need to substitute that. Okay, here also the as of previous problem, last problem that I have dealt with the session, right? So we need to here find the value of x, we need to find the value of x by the substitutions. Okay, yeah, so now it's solve. So here put the values for a and b. So this is again of the reverse form, a plus bx, right? So here the value of a here is minus 1 and the value of b here is coefficient of x is 2. Okay, so a is equal to minus 1. See, this is minus 1. Okay, since there the formula is of a plus bx, but in the bracket we have 2x minus 1, right? So the value of b also here is 2. So now our e power z is equal to minus 1 plus 2x, right? Also log of minus 1 plus 2x is equal to z, right? So here in order to find the value of x, this equation is the easiest one, right? Yeah, so we can write e power z. So bring minus 1 to the side, it will be plus 1 is equal to 2x. So x value we get it as e power z plus 1 by 2, right? Yeah, so now put that value in this equation, that is 8x square minus 2x plus 3, that is your r of x. So now this would be, so yeah, let's make one step, that is, this is not a division. Okay, I've just put in a box here to solve. So we can split this 8x square and write it as, since this is x square, right? So if you put the value of x as this, it would be e power z minus plus 1 by 2 the whole square. So in order to solve this, that would be a difficult one. So you can split and write this 8x square as 4x into 2x, okay? And the rest of the terms write it as it is, minus 2x plus 3. So now we can solve this in an easier manner, okay? 4 into, substitute the value of x as e power z plus 1 by 2, 2 into, again e power z plus 1 by 2, minus 2 into e power z plus 1 by 2 plus 3, right? Yeah, so now multiply this 4, so it would be 4 e power z by 2 plus 4 by 2, right, into 2 e power z by 2 plus 2 by 2 minus 2 e power z by 2 plus 2 by 2 again plus 3. So here 2 by 2 will become 1. So this is again 1. So left out terms are here 2 1s are 2 2s are 2 1s are 2 2s are, right? So 2 e power z plus 2 into e power z plus 1 minus e power z plus 1 plus 3, right? So we need to be very careful by solving this, okay? So yeah, so now let's multiply these terms, right? 2 e power z into e power z, that is 2 e power 2z, right? 2 e power z into 1, again 2 e power z plus 2 e power z, 2 into 1 is 2 minus e power z plus 1 plus 3 is 4. So our final answer is 2 e power 2z, 2 e power z plus 2 e power z, that is 4 e power z, and also we have a minus e power z, so it will be 4 minus 1 is 3 e power z, along with the constant term, that is 2 plus 4, that is 6. So by solving this whole thing, we got the r of z. We have replaced r of x as r of z. Okay, yeah, so we need to be very careful by solving this. Okay, so now again replace few more substitutions, right? We have not done it, that is 2x minus 1 the whole square d square y by dx square is b square, so the value of b is 2, so 4d d minus 1 into y. Also 2x minus 1 dy by dx is equal to, the value of b is 2, so 2 dy. So now let's write this thing in the equation, the given question, that is 2x minus 1 whole square d square y by dx square. So that is replaced by 4d d minus 1 into y plus 2 dy minus 2y is equal to this term, 2 e power 2z plus 3 e power z plus 6. Okay, yeah. So now multiply 4d again, 4d square minus 4d plus 2d minus 2 is equal to 2 e power 2z plus 3 e power z plus 6, right? So we get 4d square minus 4d plus 2d is equal to minus 2d minus 2 is equal to 2 e power 2z plus 3 e power z plus 6. Yeah, so we have got it. So now again we need to put d is equal to m here, so we get it as 4m square minus 2m minus 2 equal to 0. For this now we need to find the roots by using the quadratic formula. So now let's solve this. The value of b is minus 2, so it will be 2 plus or minus square root of 2 square is 4. Again we have minus, so this will be plus 4 into 2 into 4, that is 32 divided by 2 4s are 8. So we get m is equal to 2 plus or minus square root of 32 plus 4 is 36 by 8, that is 2 plus or minus 6 by 8, right? So we get m as either 2 plus 6 by 8 or 2 minus 6 by 8, that is 2 plus 6 is 8 and 2 minus 6 is minus 4, so this is equal to 1. 4 ones are 4 2s are, so therefore our roots are 1 comma minus half. Okay, so now our complementary function would be written as c1 e to the power z, okay, plus c2 e to the power minus 1 by 2 z. Okay, yeah, so now let's find the particular integral. 1 by f of d into r of z. So ip is, r of z is given as 2 e power 2z plus 3 e power z plus 6 divided by f of d is 4d square minus 2d minus 2. So again this is splitted in 3 terms, right? So we need to find yp1, yp2 and yp3. So the first term is 2 e power 2z divided by 4d square minus 2d minus 2, where the value of we need to replace d by a according to the first type, where value of a is 2, so we get 2 e power 2z divided by 4 into 2 square minus 2 into 2 minus 2, we get it as 2 e power 2z divided by 2 square is 4, 4 4s are 16, 2 2s are 4 minus 2, we get 2 e power 2z divided by 16 minus 4, 12 minus 2 is 10, 2 1s are 2 5s are, so we get our finally yp1 as e power 2z by 5. Okay, so now similarly let's find for yp2, that is 3 e power z divided by the f of d term, 4d square minus 2d minus 2. where again the value of a here is 1. Okay, so we get 3 e power z divided by 4 into 1 square minus 2 into 1 minus 2, that is equal to 3 e power z divided by 4 ones are 4 minus 2 minus 2, so we get yp2 as 3 e power z by 4 minus 2 minus 2 is 0. Okay, so now we need to take the derivative of f of d, that is f dash of d, right? So I will solve it here only. The f dash of d, the given term is 4d square minus 2d minus 2. Let's take the derivative. We get 8d minus 2, right? So now it would be yp2 is equal to 3z. Since we have taken the derivative, 8d minus 2, but the value of a here is 1, so yp2 we will be getting as 3z e power z divided by 8 minus 2 is 6. 3 ones are 3 twos are, so finally we get yp2 as z e power z by 2. Okay, so this is visible, right? Z e power z by 2. Okay, so this is your yp2. So now we will solve for yp3 also. So the third term is 6 divided by 4d square minus 2d minus 2, where here the value of a is 0, right? So we get 6 divided by 4 into 0 square minus 2d minus 2, so we get 6 divided by this is 0, 2 into 0 minus 2, so minus 6 by 2, that is 2 ones are 2 threes are, so our yp3 we got it as minus 3. Okay, so now let's write yp, that is yp1 plus yp2 plus yp3. So we'll got our yp as yp1 we got it as 2 e power z, yp1 we got it as e power 2z by 5 plus yp2 we got it as z e power z by 2 minus 3. So this is the required particular integral. Okay, so now we will write our y term, that is yc plus yp, where we got yc as c1 e power z plus c2 e to the power minus 1 by 2z, right? Plus the particular integral we got it as e power 2z by 5 plus z e power z by 2 minus 3. Okay, so now we need to replace few of the terms here again, that is we have both e power z along with the z, so we need to replace z by log of minus 1 plus 2x and also e power z by minus 1 plus 2x. Okay, so we get finally our general solution as y is equal to c1 e power z is equal to minus 1 plus 2x, right, plus c2 e to the power minus 1 by 2 into log of the value of z here is minus 1 plus 2x, right, plus e power 2 log of minus 1 plus 2x again divided by 5, plus I write the other term down, that is log of minus 1 plus 2x into e power z is again minus 1 plus 2x, right, z into e power z divided by 2 minus 3. Okay, so now we can cancel few terms here, that is here if we cannot cancel, but we can use the formula b log a. So this would be log of minus 1 plus 2x the whole square, so we can cancel e and log here. So here also we can cancel e and log, and this power, it should be the power of this term. Okay, so now y is equal to c1 into minus 1 plus 2x plus c2 into minus 1 plus 2h to the power of minus half, right? Also we can write this as square, so this would be 1 by half, so 1 by square root of minus 1 by 2x. Also we can write it that way also, or else we can keep it as it is, plus e and log gets cancelled, so the remaining term is minus 1 plus 2x to the power square divided by 5 plus log of minus 1 plus 2x into minus 1 plus 2x divided by 2 minus 3. Yeah, so this is your final answer. So we can keep this as it is, or else we can even further solve this by doing some of the simplifications as I have told you here. Yeah, so this is your final general solution. Okay, so this is again a very important question. Okay, please make a note of this. So we have one more problem similar to this one, so we'll solve that. So this is your last question of this session and also this module also. So the question is 3x plus 2 the whole square into d square y by dx square plus 3 into 3x plus 2 into dy by dx minus 36y is equal to 3x square minus 4x plus 1. So this is again similar to the previous problem only. Yeah, so here the value of a is 2 and b is 3. Okay, so again we can write it as e power z, we can write it as 2 plus 3x, right? Also we can write z is equal to log of 2 plus 3x. Okay, yeah, so now in order to find the value of x, bring this 2 to one side, e power z minus 2 is equal to 3x, so we get our x as e power z minus 2 by 3. So now substitute in the value of in the place of r of z here, so we have our r of x as 3x square plus 4x plus 1. So where the value of x we need to substitute this value again. So now again let's split this in order to make our problem easier. That is, we can split and write it as 3x into 1 by 3x. Okay, you can write it as 3x into 1 by 3x, since 3x into 1 by 3x is again corresponds to 3x square only, plus 4x plus 1. So now substitute the values of x here, e power z minus 2 by 3, 1 by 3 into e power z minus 2 by 3 plus 4 into e power z minus 2 by 3 plus 1. So now multiply this, we get it as 3 e power z by 3 minus 6 by 3, right? 3 to the 6 and we have 3 here, and also we get 1 by 3 into e power z by 3, that is e power z by 9 minus 2 by 9 again, 3 3 is a 9, plus 4 e power z by 3 minus 8 by 3, correct, right? Yeah, plus 1. Okay, so now by further solving we can cancel this 3 here, 3 1s are 3 2s are, and yes, other terms we cannot cancel it, so we get e power z minus 2 e power z by 9 minus 2 by 9 plus 4 e power z by 3, and solve this by taking the LCM. So we have 1 minus 8 by 3, so we can write it as minus 8 plus 3 by 3, minus 8 plus 3 is minus 5, so we get minus 5 by 3, right? Yeah. So now let's multiply these two terms. We get it as e power z into e power z by 9, that is e power 2z by 9, e power z into 2 by minus 2 by 9 minus 2 e power z by 9 minus 2 e power z by 9 again, yeah, plus 4 by 9 into, we can write it as 4 e power z minus 5 by 3, since the denominators are same right here. Okay, yeah, so we need to further solve this because this is a bit lengthy problem. Okay, so now we can write it as here all the, we have here 9 9 9 9, we can add them. E power 2z minus 2 is minus 4 e power z plus 4 by 9 plus 4 e power z minus 5 by 3. Okay, so here again take the LCM for this term, that is multiply 3 through this whole term, that is 3 e power 2z minus 4 3s are 12 e power z plus 12 plus again multiply 9 to this term, 36 e power z, 9 5 is 45 divided by 9 3 is 27. Okay, so we get it as 3 e power 2z, 36 minus 12 is plus 24 e power z, 12 minus 45, so 45 minus 12 is 37, so 12 minus 45 would be minus 37 upon 27. Yeah, sorry, 45 minus 12 is 33. Okay, 12 minus 45 is equal to minus 33. Okay, yeah, so we can even split this now, that is we can write it as 3 e power 2z by 27 plus 24 e power z by 27 minus 33 by 27. So here we can see that 3 1s are 3 9s are, right? Also 3 8s are 3 9s are, 3 11s are 3 9s are. Okay, so here again 9 is there common, so e power 2z plus 8 e power z minus 11 by 9. So this term we got it as our r of z by solving. Okay, so now we need to do some more calculations, that is we need to substitute few more values. So we need to substitute few more values, that is 3x plus 2 the whole square b square y by dx square is equal to, the value of b is 3, so 3 square is 9 dd minus 1 into y, right? Also 3x plus 2 dy by dx is equal to, again the value of b is 3 dy. Okay, so these values we need to put in the equations. Okay, so here I have done this whole process step by step. Okay, so please observe this very carefully while solving. We cannot make even a single mistake, because this equation we need to bring this in the form of r of z. Okay, yeah, so now let's solve it. Okay, so now we'll put the values of substituted values, we'll put it in the equation, that is 9d into b minus 1y plus 3 into 3 dy, right? We had 3 already, we had a 3 in the question, right? Yeah, minus 36y is equal to, we got it as e power 2z minus 8 e power z minus 11. So wait, I'll check it with whether it's minus or plus. Yeah, it's plus, right? By 9. Okay, so here again we have 3 terms, we have split it into 3 terms. Okay, so that we need to find yp1 yp2 yp3 again. Okay, Yeah, so now let's solve for this term, that is multiply 9d square minus 9d, 3 into 3d is again 9d minus 36 into y is equal to e power 2z by 9 plus 8 e power z by 9 minus 11 by 9. Okay, yeah, so minus 90 plus 90 goes 9d square minus 36 into y is equal to e power 2z by 9 plus 8 e power z by 9 minus 11 by 9. Okay, so now the rest of the thing remains the same again. Put d equal to m, auxiliary equation condition, so 9m square minus 36 is equal to 0. So bring this 36 to other side, equal to plus 36. So m square we get it as 36 by 9. So m square is equal to 9 ones are 9 fours are 4. So m we get it as plus or minus square root of 4. M is equal to plus or minus 2, right? So our complementary function is plus or minus 2. So c1 e to the power plus 2z plus c2 e to the power minus 2z. Okay, yeah, so now we'll solve for the particular integral, that is what we got, r of z e power 2z plus 8 e power z minus 11 divided by 9 into f of d, right? Yeah, so f of d is 9d square minus 36, right? E power 2z plus 8 e power z minus 11 is equal to, multiply this 9 nines are 81d square minus what we got, 36 into 9. So 36 into 9 is equal to 324. Okay, yeah, so now we need to solve this separately to find yp1, yp2 and yp3. So yp1, take the first term e power 2z 81d square minus 324, right? So here the value of a is 2, so yp1 would be 81 into 2 square minus 324. So we will get yp1 as e power 2z divided by 81 into 2 square, 81 into 4. So what would get 81 into 4? Again we got 324, or also we have another 324. So we get yp1 is equal to e power 2z by 0. So now we need to take f dash of d. We have given f of d is 81d square minus 324. So we get 81 2s are 162d, right? 81 2s are 162, right? And the derivative of 324 is 0. So we get yp1 as now z e power 2z. So since we have taken the derivative 162 into 2, right? The value of a is 2, so we get yp1 as z e power 2z upon, again what's the value of 162 into 2, 324. So this is our yp1. Okay, so now we are remaining to solve yp2 and yp3. We'll solve it. So our yp2 term is 8 e power z divided by 81d square minus 324. So 8 e power z, the value of a is 1, so 81 into 1 square is again 1 minus 324. So we get 8 e power z divided by 81 minus 324. 81 minus 324 minus 243. Okay, yeah, so our yp2 term corresponds to 8 e power minus of 8 e power z by 243. Okay, so now similarly let's find for yp3. is equal to 11 divided by 81 in d square minus 324. So I get yp3 as, so in the value of a is 0, so 11 divided by 81 into 0 square minus 324. So we get our yp3 as minus 11 by 324. So can we further solve this? Let's check it. 11 upon 324. No, we cannot solve it. See, we are not getting the simplified form of this fraction. So yeah, we need to keep it as it is. Okay. So now our yp should be equal to yp1 plus yp2 minus yp3, right? Because here we have plus term, and also if you want to find yp3, I have taken it as 11 here, right? I have not taken it as minus 11 here. See, I have taken it 11 since we have here minus sign. So the similar way we need to substitute the values for yp1, yp2, yp3. Okay. Since I have taken yp3 only 11, I have not taken minus 11. See, yeah. So our yp would be yp1, what we have got, z e power 2z upon 324 minus 8 e power z upon 243, and we have here minus, also here we have minus, so plus 11 by 324. So this is your required particular integral. So now let's write y equal to yc plus yp. Okay. So here we can further simplify it. So here in the place we have, here we have 324, but here we have 243, right? So in the simplified form we can write it as, so this corresponds to 81 into 4, but this is 81 into 3, right? So we can multiply another 81 here. Okay. So we can add another 81 here, that is, no, it's not possible. Yeah, so no, it's not possible. This is only our final term. Okay. Yeah, so no need to simplify, keep it as it is. And yc term we got it as c1 e to the power 2z plus c2 e to the power minus 2z plus yp we got it as z e power 2z 324 minus 8 e power z by 243 plus 11 by 324. Okay. So now replace e power z equal to and log of 2 plus 3x is equal to z. Okay. So now write our general solution would be y equal to c1 e to the power 2 log of 2 plus 3x plus c2 e to the power minus 2 log of 2 plus 3x, right, plus z is log of 2 plus 3x into e to the power 2z, that is e to the power 2 log of 2 plus 3x. Again write all the terms very carefully, divided by 324 minus 8 e power z is 8 into 2 plus 3x upon 243 minus 11 by 324, right? Yeah, so now let's cancel some of the terms. So if we bring this 2 up here square, so e and log gets cancelled. So here e and log gets cancelled, this minus 2 goes here up. So here again e and log gets cancelled, this 2 goes here up, and Yeah, so now let's write our final answer. So this is your required answer, okay, after simplifying few terms, that is e and log power goes, so this term remains 2 plus 3x the whole square, and here again e and log power goes, but we had 2 plus 3x to the power minus 2. Since minus 2 is there, so I brought it to the denominator, so it becomes plus 2, that is 2 plus 3x the whole square, c2 divided by 2 plus 3x whole square, and plus log of 2 plus 3x into e and log gets cancelled again, 2 plus 3x whole square by 324, this is minus, okay, minus 8 into 2 plus 3x by 243 minus 11 by 324. So this is your general solution. Yeah, so this completes this module. So I know that this Legendre's equation was a bit tough, okay. Yeah, but we have completed this module successfully. So now we have left with only one module to cover, that I am going to cover it very soon. That's an easy module. I am going to cover it within 4 to 5 sessions, okay, as I've solved those questions and kept it, okay. I am not going to solve it again, I am just going to explain you all, okay. That's a very easy module, and there are few derivations, okay, 1 or 2 derivations that are very important ones, those only I am going to solve it. Yeah, so this completes the module. If you have any doubts, please comment down. Please like, share, subscribe if you have any interest listening to this session. So please study well, and please score good marks. I have provided all the important questions to you all. So yeah, that's all for this module. We have completed this module successfully in around 12 sessions, I guess. Yeah, that's all for it. That's all for today. Thank you.